Good morning, everyone. This is Automotive Air Conditioning and Auxiliary System, practical number 1. The practical is vapor compression refrigeration. And objective of this experiment is to understand the operation of a simple vapor compression refrigeration cycle and to evaluate the performance of different type of expansion valve. By looking this basic cycle, you can see the step 1 to 2 is we say it as isentropic compression, right? In here the refrigeration will be compressed inside the compressor. So the compressor, by using compressor we will give some works, right? So W in, that's mean works in, right? From step 2 to 3 we call it as constant pressure heat rejection, right? From the condenser heat will be rejects to the environment, right? Step 3 to 4 call it as throttling in an expansion device, right? In here pressure will be decreased and that refrigeration will be supplied to the evaporator. Then the last step is 4 to 1, that call it as constant pressure heat absorption in an evaporator, right? That means from the evaporator the heat will be absorbed by the refrigerant again, right? Then it will be supplied to the compressor, then condenser and expansion valve. Likewise it will rotate, right? Then the heat absorbed in the evaporator will be rejected in the condenser. That is the basic cycle of the vapor compression refrigeration system, right? And from this experiment we are going to evaluate the performance of different type of expansions valve. Let's move to the experiment. Here you can see this is the experimental setup. In here we have three different type of expansion valve, so that by changing the expansion valve we can evaluate the function of different type of expansion valves here. And in here you can see this is compressor, right? Inside of this box you can see there's a condenser, right? So other part is, this one is evaporator, but it is made by transparent tube, right? So that we can observe the phase change of that refrigerant, right? Because inside of the evaporator there will be a phase change, right? Liquid and vapor phase change, right? Here you can see there are three valves, right? Those three are the three different expansion valve. First one is automatic expansion valve. The second one is capillary tube expansion valve, right? The third one is thermal electric expansion valve, right? So when we are using this refrigeration cycle, we have to open one and we have to close other two, right? Likewise we can use three different expansion valve and we can check the performance for each of that expansion valve, right? By calculating coefficient of performance, right? To calculate the coefficient of performance, right? COP for the cycle, right? Then we have to take some readings, right? The temperatures of inlet outlet temperature for the compressor, condenser, evaporator and expansion valve, right? Those things we have to measure, right? For that we have to we can use thermostat, right? Here. And to calculate, by if we calculated that readings temperatures, then we can calculate the coefficient of performance. then we have to change to the other expansion valve and we have to redo the practical. Likewise, we will get different performance coefficient of performance for different expansion valve, right? First we have to understand this cycle, right? For that, this is, you can see, one is there's a compressor and one is inlet and other one is outlet, right? If you know that, if you remember that basic cycle, you should know the compressor will be connected with the evaporator and the condenser, right? Now I will explain this cycle here, right? We will understand the each part and inlet outlet, right? And here this is inlet, right? Inlet of the evaporator, right? That evaporator inlet will connect with the compressor, right? Evaporator inlet will be connected with the compressor, right? Then that compressor outlet, this is a refrigerant path, right? The compressor outlet will be connected with the condenser inlet, right? Then only that heat will be rejected to the environment, right? This is condenser, you can see. Then you know the cycle, right? After the condenser there will be expansion valve, right? Then this is condenser outlet, right? Then from this condenser outlet, the refrigerant will be supplied to the expansion valve, right? Expansion valve. But in here you can see it will connect with the expansion valve, but there's a same path for that expansion valve and the condenser and also the evaporator and the compressor, because there is a heat exchanger. That is a thing you have to understand here, right? Then refrigerant from this condenser to expansion valve, right? Going through that heat exchanger, right? This is expansion valve, right? This is heat exchanger tube, right? There's a two-way flow inside of that tube, right? That is the thing you have to understand, right? One flow is condenser and expansion valve, other one is evaporator and the compressor, right? Then from that expansion valve you can see the refrigerant will be flowed to the evaporator, right? And here you can see evaporator is made by transparent tube, right? And here I think you all understood this cycle here, right? The complex thing is here there's a heat exchanger. That is a thing you have to understand, right? Okay, now the refrigeration cycle is running here, and let's take the temperature, right? Now it is that automatic expansion valve is activated, other two are closed, right? That means in this cycle we are using automatic expansion valve, right? So to measure this, to calculate this is coefficient of performance for this automatic expansion valve, we have to measure the inlet outlet temperature for each part of the cycle, right? So to measure the temperature we are using thermostat and the multimeter, right? By placing the thermostat in that place where we need to measure the temperature, right, we can see the temperature of that particular place, right? You can see now it is showing that environmental temperature, right? Room temperature. This is the edge of this thermostat, right? Now it is 129 degrees Celsius. Now this is the inlet of the evaporator, right? To measure the temperature, we have to place that thermostat there. Now you can see this is 10 degrees Celsius, right? That means the evaporator inlet temperature is 10 degree. This is outlet of the evaporator. Now by placing that thermostat there, we can measure the outlet temperature also same, right? For the evaporator, right? Then we have to measure the inlet and outlet for the compressor, and compressor inlet temperature is 16 or 15 degrees Celsius. Now we will measure the compressor outlet, right? Compressor outlet is 34, right? It should be high, right? Higher than the room temperature. And you can see here, right? Compressor outlet and the condenser inlet are same, right? So we don't need to, this is compressor outlet and the condenser inlet, right? Those should be same, right? Now we will measure the condenser outlet, right? Condenser outlet temperature is 36 degrees Celsius, right? It should be lower than the 34, right? It should be lower than the compressor outlet, right? Because from the condenser some heat will be rejected to the environment, right? And then after that condenser, it will go to the expansion valve, right? This is the expansion valve inlet, right? So we will see it is 22 degrees Celsius, the inlet temperature of the expansion valve, right? Now we have to measure the outlet temperature of the expansion valve, right? It is 15 degrees Celsius, right? After that, refrigerant flow to the evaporator inlet. Likewise, we already measured that inlet temperature of the evaporator. This is, now it is aquator now. If you want to change do it for this, for different another type of expansion valve, we have to close that one and we have to open another one, right? For that we have to stop the cycle and we have to restart the cycle, and we have to repeat this process, and from that we can be able to evaluate the performance of the different type of expansion valve. And this is your observation data. So for your lab report calculation and results, those things you have to find using this observation data. So by using this data, you can find the enthalpy value for each stage of that refrigeration cycle. Then by using that enthalpy values, you can calculate the coefficient of performance, right, for refrigeration cycle and the heat pump. So likewise you have to calculate the COP values for each type of expansions valve. Now let's see about the lab report submission. In your lab report, you have to write down the introduction and theory, and there should be a calculation for each type of expansion valve, right? And you have to tabulate the results, right? Then you can differentiate that function of that different type of expansions valve, right? Then you have to answer the discussion questions, right? This is end of this practical. Thank you.